Hi guys, this video is just basic understanding of what internal resistance is. So I'm just going to go through a little bit of the basics and then in a different video I can do some examples. Okay, so the first thing we're going to talk about is that in grade 8, 9, 10, we did not do internal resistance. We only talked about the potential difference or the voltage within a circuit. So we would have our battery over there, our cell. We would then have, like, let's say, an ammeter. We would then have a resistor. Okay. We would then come across and maybe we would have a second resistor. And then we would complete the circuit. And we said that each of these resistors is then going to use a certain amount of voltage. You add them together and they equal what is over the cell. Okay. That's what we said in previous grades. But that's not actually true. Okay. We now, oh, that's not an eraser, we now need to take into account the internal resistance of the actual battery itself. Okay, so it's a little bit different. So in matric, in grade 11, where we start teaching it, it used to be a matric topic, but now they've taken it to grade 11. We teach it in grade 11 because there's no time in matric to teach it. So in matric, we now have to take the resistance of the actual battery into consideration. Okay, normally a cell or a battery would look like this: a long line and a short line. We know the long line is a positive and the short line is a negative. Okay, that's very normal. But now we don't just do this. We need to now take into account where some of that extra charge is going. Okay, so instead of just drawing a long line and a short line, we then also need to add a resistor to our diagram. Okay, we're going to extend the lines out like that, and then around the battery and the resistor, we're going to have this dotted line, which represents that this is the whole of the battery. This is where the power is coming from, and that inside the battery, there's actually something called internal resistance. Okay, some of the energy inside a battery needs to be used by the battery to do work. This work is now the current that gets pushed through the circuit. So we now need to take into consideration that the battery needs to do its job. And to be able to do its job, it needs some energy. And where is that energy going to come from? From this resistor. So if I tell you that this whole battery is 12 volts, okay, its potential difference is 12 volts. That means in this field here, in this dotted line, it's 12 volts. But then I tell you that the resistor needs to use 0.8 volts to be able to push the charge through the circuit. How much is this cell actually providing? That would then be 11.2 volts, okay, which would then equal to the 12. So we need to start taking this internal resistance into consideration when we are talking about electric circuits now, okay? So just as a little bit of a revise from grade 10, we know that EMF, the electromotive force, the EMF, okay, so remember it's your EMF, can also be signified with this backwards facing 3, that is an epsilon, okay, it's your EMF. Your EMF is the maximum potential difference when the circuit is not connected. So meaning when the circuit is open. So when the circuit is open, it is said then to have EMF, not current, okay, not potential difference, okay. Only when it is open can we then have EMF. And when the circuit is open, do you think that this resistor then needs to do work? No. So when the circuit is open, so let's just draw a little circuit here. There's your, well, yeah, let's just erase that one. Okay, here's your eraser. Sure. Okay, let's just erase that little part there. So when we are drawing our circuit, we're going to have this as your open. Okay, so that's your open circuit. And let's just put in a light bulb just so that we know that it's doing work. Okay, so when you have an open circuit like this, we know that this voltage, the potential difference here, is all of that. It's the 12 volts because the circuit doesn't need to do any work. So it doesn't need to take the 0.8 into consideration. So it only has EMF. There is no need for that 0.8 to be given to the resistor to push the charge through the system. It stays as 12 over here, okay? So that is the main difference, is that EMF is when the circuit is open. And when the circuit is open, there is no need for the resistor to do work. And if there's no need for the resistor to do work, then obviously there's no need for the internal resistance to be there. So we can just then say that this cell, this battery, is 12 volts, okay? But when the circuit now becomes closed, now this battery needs to do work. And when something needs to do work, we need to take this internal resistance into account. Okay. So then we move on from EMF to potential difference. So I normally just say PD, potential difference. Potential difference or voltage. We don't like to say voltage. It's not the correct scientific term. So we say potential difference. Potential difference is the voltage across the terminals of the battery when the current is flowing. So here's the battery, okay? So here's the one side, here's the other side. Your voltmeter gets attached over the battery. So what is exiting the battery and what is entering the battery is being measured by this voltmeter. And this is why voltmeters need to be in parallel, because they're measuring how much is exiting and how much is coming back. So we can then see what it's actually measuring. Okay, so we call this potential difference, we call this terminal voltage because it is measuring the terminals. So this potential difference is also known as V terminal. Okay, so we can call it V terminal. Another one is also V external. Okay, external voltage is your potential difference. This is now the voltage that the rest of the circuit experiences. Okay, sometimes in some textbooks and in some documents, it's called V load. Okay, so potential difference can either be V terminal, V external, V load. I like to use V external because it's talking about the external portion of the circuit, okay? Not this internal, where internal resistance plays a role. It's the external. So that's why I like to use the V external or VEXT for external, okay? So that's how I like to refer to it. You're allowed to refer to it however you want, as long as you can represent what you're trying to find out. Okay, so there you go, choose a new one. So we already talked about how when the switch is open, it is then reading EMF, and EMF would then be the total voltage. Okay, so that total voltage within the EMF we call V internal. Okay, so V internal and V external. Okay, so V internal is the EMF, and V external is the potential difference. This is when the circuit is open, and this is when the circuit is closed. Okay, so there's a big difference between potential difference and EMF, and then we label it slightly different as well. V internal, V external. Okay, another word for V internal, sometimes we can say V lost, because it is the voltage that is lost to the resistor to be able to do that work. Okay, so it's also the lost volts or the internal voltage. Okay, a nice way to look at it is that the EMF is equal to the V external plus the V internal. Okay, so this V internal would be that 0.8 volts that the resistor was using to do work, to push the current through the system, and the V external was that 11.2 volts that we worked out on the rest of the circuit is then using, and that would then come to your 12 volts that we originally had in the previous slide. Okay, so this is a really nice example to an equation to use Obviously not on the data sheet, but it's a nice example to use to be able to work out either EMF, V external or V internal. So just remember this, write it down somewhere, fluff it out a little bit so that you know what each one is, and then you can work from that. Okay, so a key concept is to know that when question says the voltage across the terminals of the battery drops, so the voltage across the terminals drops, they are telling you that they mean the external. Okay, so when they say the terminal voltage drops, they are telling you that the V external is dropping, is decreasing. Okay, so it's just one of the concepts that come up in a lot of past exam papers, is that the question will say that the V terminal is dropping, or the terminal voltage, or the voltage across the terminals drops. They are saying that the external voltage is dropping, not the internal. The external is dropping, therefore we need to take the V internal into consideration. Okay, and when we take the V internal into consideration, we know that we are working with potential difference and not EMF. Okay, it's a very big thing to think about, but as long as you are understanding when they're asking the questions about terminal dropping, you know it's the external dropping, therefore we need to take V internal into consideration. Okay, so your main equation is that epsilon, is that EMF is equal to I R plus R. Okay, none of these things should be new to you. We do EMF in grade 10. So this is your EMF, and EMF is always measured in volts. Okay, it's not potential difference, it's EMF. Please do not get that confused. It's not PD and it's not V external. Okay, EMF is your total voltage. Okay, so it's not just the external voltage, it's the V external. So V external and the V internal together is your EMF. Please do remember that. Okay, I has been I since grade 8. Okay, so I is your current, it's your current strength. Please remember that current is I, but it's measured in amps. A lot of kids get that confused. Okay, so it's current, which is I, is measured in amps. The big R, we've been dealing with our whole careers in electricity. Big R is resistance. Okay, and we know resistance is measured in ohms, but now this big R is your R external. Just like this is V external, this is R external. So it's the resistance in the main part of the circuit. So if you had a resistor here, you had a resistor here, and you had a resistor here, it would be all three of these resistors added together. It does not include the resistor that is in the battery. Okay, it does not include that. So make sure big R is the external resistance that the circuit is experiencing with all the resistors, not including the internal resistance. Okay, this baby R is the internal resistance. Okay, that's what this baby R is. So it's R internal. Okay, this is now representing the resistance inside the battery. It is offering that resistance so that it can get work done. Okay, because whenever energy is being used, whenever work is being done, there is going to be some form of resistance. So now we need to take that into account now that we're in grade 11 and 12. Okay, so I hope that made a little bit of sense. So with that one equation, that E equals I R plus R. It's on the data sheet. You don't have to learn it off by heart. It's there. This equation is pretty self-explanatory. Okay, so remember this I is the I total, the total current for the whole circuit. Remember, in a series circuit, the current stays the same no matter where you put it. In a parallel circuit, this current will be divided. But you normally either know the total current or there's some way to find the total current and you can insert it in here. EMF is either given or you can figure it out or something. Big R and little r, you can work out generally. Normally, big R you can work out because they will give you the resistance of all of the resistors. Sometimes this is given, sometimes it's not, sometimes it's what they want you to find. Okay, so this is your main equation. But the other equation we've been learning since grade 8 is R is equal to V over I. Please remember, this is how it is said on the data sheet. However it is written on the data sheet is how you must use it in your exam. Please don't rearrange it to suit your purposes. You leave it as it is. R is equal to V over I, and then you substitute in as it is. Then you can redo it however you want and to get your answer. But don't rework it before you've written it down as R is equal to V over I. Okay, so this is our general one. It's the same equation we've been using since grade 8, grade 9. But we can now manipulate it a little bit so that it represents what we want it to represent depending on what question is asked. Okay, so if the question is asking you to find V external, then we know that R will be external. It will be the external R, which is V external over I. I is always going to be I total, I external. Okay, so it's still I, doesn't matter with the I. But if you are asked to find V external, you are going to use R external, not R and R like here. Okay, it's not both of those R's together. It's just the R external, the ones that are in series and parallel. Okay, just like this V external is your total voltage around the rest of the circuit, not including the V lost. Okay. The other way we could do it is obviously instead of doing external, it is R internal equals V internal over I total again. Because remember, ammeters, it doesn't matter where you put them, the reading stays the same. So it will be the same for this equation as it is for this equation, as it is for this equation. Okay, so you can manipulate this equation to represent how and what you want to use it for, depending on what the question is asking. Okay, so these are the main concepts of internal resistance. You need to make sure that you are understanding your V external versus your V internal. Sometimes they'll say V lost, sometimes they will use other ways of phrasing it, but please do make sure that you understand this concept so that you can answer questions relating to internal resistance. Okay, I hope this helped a little bit. My next video will be doing an example of internal resistance so that you can see how we use these equations in a question. Okay, thank you, bye.